Hi guys, welcome once again to another interesting math problem. In today's tutorial, we have something on logarithmic equation, something of a different dimension, very unique but simple, though looks bogus. So let's go and see the problem and the solution as always. So we have a rather scary, humongous logarithmic equation here. We have log to the base of 2s plus 3 of the argument 6s squared plus 23s plus 21 minus log to the base of 3s plus 7 of the argument 4s squared plus 12s plus 9 equal to 2. As you can see, this looks very strange, but we shall devolve it by applying some of the fundamental laws of logarithm. Please, you need to stay tuned, watch this video from the beginning to the end. If you are a new subscriber or today is your first time of encountering this channel, please do well to subscribe and smash the bell notification icon so that you can be notified anytime I upload a new content. So let's go back and see the solution of this problem step by step. Trust me. Okay, first time I saw this problem, what actually came to mind is the fact that is the quadratics in this equation factorable. Once you test that and they are factorable, this entire problem is simple, though very bogus. So we shall do that. I will start by taking the first quadratic, 6s squared plus 23x plus 21. 6 multiplied 21, that is 126. Two factors of 126 that can give 23 when added are 9 and 14. So I will then write 6s squared plus 9x plus 14x plus 21 and then group. 6s squared and 9x, what is common? That's 3x. I'll write out 3x. 3x divides 6s squared, that's 2x. 3x divided 9, that will be 3. Then 14s and 21, what is common? That's 7. 7 divided 14x, that's 2x. 7 divided 21, that's 3. So you can see the two entities are the same. So we pick the outside factors and write one of these entities. So in place of 6s squared plus 23s plus 21, we shall infuse or substitute 3s plus 7 and 2s plus 3. Okay, that will simplify the outlook of this problem. Okay, then I will take the next quadratics, which is the anti-log argument. 4s squared plus 12x plus 9. 4 is a square number, 9 is a square number. This is pretty easy, very primary and basic. I can write 4s squared to be 2s all squared, 12x, 3 squared. Because of this square number here and here, this expression is actually a perfect square. So to test it, 2s multiplied 3, 6. 6 multiplied 2, that's 12x. So this is analogous to a squared plus b squared plus 2ab. So the answer becomes 2s plus 3 all squared. So in place of 4s squared plus 12x plus 9, I will substitute 2s plus 3 all squared. So that will simplify the entire problem. So I will take this off. Then I will write log to the base of 2s plus 3. The argument 3s plus 7, 2s plus 3, minus log to the base of 3s plus 7. We have 2s plus 3 all squared, everything equal to 2. This is the very punchline, the weak link in solving this problem. Then here, okay, I will recall a very fundamental law of logarithm, multiplication slash addition law. So I have log to the base of a of the argument bc. I can split this to be log to the base of a of the argument b, log to the base of a of the argument c. Some people call it the product rule because for them, product sum product, multiplication slash the addition law. So with this here, we'll separate these guys. Then again, the power rule. If the argument or antilog of a logarithmic function is raised to an exponent, the exponent becomes the coefficient. So these two will come to the back of this log to become a coefficient. So with these two laws, we will write this problem to be log to the base of 2s plus 3 of the argument 3s plus 7 plus log to the base of 2s plus 3 of the argument 2s plus 3 minus 2 log to the base of 3s plus 7 of the argument 2s plus 3, everything equal to 2. So you can see this quantum leap here that's going to lead us to the destination. Then here we have log of the base of 2s plus 3 and the argument 2s plus 3. So this is 1. Because log to the base of a log, log to the base of a of the argument a is equal to 1. This is true for numbers or letters or even expression like we have here. So log to the base of 2s plus 3 of the argument 2s plus 3 is 1. So with this law, we will rewrite this entire problem to be, this one will cancel out, log to the base of 2s plus 3 of the argument 3s plus 7 plus 1 minus 2 log to the base of 3s plus 7 of the argument 2s plus 3, everything equal to 2. But we subtract 1 from both sides. That will give us log to the base of 2s plus 3 of the argument 3s plus 7 minus 2 log to the base of 3s plus 7 of the argument 2s plus 3. Everything will now be equal to 1. To subtract 1 from both sides. At this level, we need to look at a fundamental law of logarithm, something that is very uncommon. If I have log to the base of a of the argument b, I could switch the base to become the argument and the argument to become the base. If I take the inverse of the logarithm, that becomes log to base b of the argument a. So you can see that log to base a of the argument b is 1 upon log to base b of the argument a. So by taking the inverse of a logarithm, the base becomes the argument and the argument becomes the base. Now, because I have established that, I can write this entire expression. This space may not be okay. I should come here. With this, let me bring this down here. It's better. Recall log to the base of a of the argument b equal to 1 all over 1 upon log to the base of b of the argument a. With this, we can then work on this guy. So I can write this to become log to the base of 2s plus 3 of the argument 3s plus 7 minus 2 multiply 1 upon log to the base of 2s plus 3 of the argument 3s plus 7, everything equal to 1. So this is the key to the solution. So I'll then make a substitution. Let u equal to log to the base of 2s plus 3 of the argument 3s plus 7. So we can then write this equation to be u minus 2 upon u equal to 1. Slow and steady wins the race, they say. So we multiply each term on the right and the left by u. That will give us u squared. I use u to multiply 2 upon u. U cancels out. That will be 2. U multiply 1. That will be u. Okay, I'll take everything to the left. U square minus u minus 2 equal to 0. So this is easy to factorize. You wouldn't even break a sweat if you factorize this directly. This is u plus 1, u minus 2 equal to 0. So u plus 1 equal to 0 or u minus 2 equal to 0. Okay. From the zero product property, we have this. So 1 goes this way becomes negative. Negative 2 goes this way becomes positive. So guys, these are the two values of u. We made a substitution that u, okay, case 1. Since we have two answers, u equals negative 1 and u equal to 2, we are going to have two cases. Case 1, when u equal to negative 1. Know that u is log to the base of 2s plus 3 of the argument 3s plus 7. So I will now have log to the base of 2s plus 3 of the argument 3s plus 7 equal to negative 1. Okay, at this level, we shall convert or transform this exponential equation, this logarithmic equation into an exponential equation. It's a bit overexcited there. So that's very simple, we shall do that. You can see that the complexity of the problem has been simplified. So we are going to have a roller coaster ride. Okay, let me take this back. So 2s plus 3, all to the negative 1, 2s plus 3 to the negative 1 equal to 3s plus 7. Now from the inverse law of indices, okay, since I have a negative exponent here, I will take the reciprocal of the positive exponent. I could write this to be 1 all over 2s plus 3 to the power of 1 equal to 3s plus 7. So this is the same thing as, since the power is 1 here, is the same. So 1 all over 2s plus 3 equal to 3s plus 7 all over 1. So we shall cross multiply this. So I'll say 2s plus 3 multiply 3s plus 7 equal to 1. So I shall expand this by this will be 2s squared plus 23x plus 21 minus 1 equal to 0. So we have 6s squared 23s plus 20 equal to 0. Is this equation factorable? 6 multiplied by 20, that's 120. 2, 5, 6, 8, 15. Okay. 8 multiplied by 15, that's 120. It can be factorized. Nice question. So 8 and 15. You add them, you have 23. So I'll go ahead. This is 6s squared plus 8x plus 15s plus 20 equal to 0. So I will group this. So you can see from the first pair of group, 2s is common. I will factor out 2x. 2s divide 6s squared, that will be 3s. 2s divide 8x, that will be 4. Okay. 15 and 20. 15 and 20, okay. 5 is the HCF. 5 divided 15s, that's 3s. 5 divided 20, that's 4. Okay, this is correct. So we take the outside factors. That will be 2s plus 3. Oh, 2s plus 5. 2s plus 5, sorry for that. Then 3s plus 4 equal to 0. So you can see the creativity involved here. So I'll take this part off. It's a big question. So from the zero product property, either 2s plus 5 equal to 0 or 3s plus 4 equal to 0. It's a simple equation, 5 crosses becomes negative, so I will have 2s equal to negative 5, or have 3s equal to negative 4. I divide both sides here by 2, I'll be having s equal to negative 5 upon 2. I divide both sides by 3 here, I'll be having s equal to negative 4 upon 3. These are the first two values for x. Then we shall consider case 2. Case 2, when u equal to 2. We know that u is equal to log to the base of 2s plus 3 of the argument 3s plus 7. If u is 2, we'll be having log to the base of 2s plus 3 of the argument 3s plus 7 equal to 2. So, exactly what we did for the first case. We take 2s plus 3, raise it to the power of 2, equal to the argument of the antilog. So this is 2s plus 3 all squared equal to 3s plus 7. We have transformed the logarithmic equation into its exponential version. So we square this. 2s squared, that's 4s squared. 2s multiplied 3, that's 6x. 3 multiplied 2x, that will be 6x. 3 squared, that will be 9. Everything equals 3s plus 7. Oh, this is the argument of the second term. Okay, 4s squared plus 12x plus 9 equal to 3s plus 7. It's also a quadratic equation. I will bring these guys to the left. So 4s squared plus 12s minus 3s, that's 9x. Then 9 minus 7, that will be 2. So this is a very simple equation to factorize. 4 multiplied 2, that's 8. 2 factors of 8 that can be 9 when added, that will be 1 and 8. Alright, 4s squared plus s plus 8s plus 2 equal to 0. This can be done directly, but for the sake of some of our audience who are still in high school, so we are doing this. So I'll group, and I'll group. I should go to this side of the board. Would you want to take chances? Okay, I'll take out s here, which is common. Then I'll have s divide 4s squared, which is 4x. S divide s, which is 1. Then I'll look to this. Okay, 8s and 2. Okay, 4 is common. Oh, 2 is common then. Okay, 2 is common. 2 divide 8x, that will be 4s as well. 2 divide 2, that will be 1. So everything equal to 0. Then again, we will use the zero product property. What we have there is s into 4s plus 1 plus 2 into 4s plus 1, everything equal to 0. Take out the outside factors because these two parentheses are the same. We have s plus 2, 4s plus 1 equal to 0. Then again, using the zero product property, it implies that s plus 2 equal to 0 or 4s plus 1 equal to 0. 2 crosses to the right becomes negative, so s equal to negative 2. Here, 1 will cross over, 4s equal to negative 1. S equals negative 2, or I divide both sides by 4, I'll be having s equal to negative 1 upon 4. Okay, so far so good. We have 4 answers, something that is very uncommon. But we shall also test for extraneous solution. It therefore means that I have to go and look for the domain of that main equation. So I will record that equation, very big, log to the base of 2s plus 3, the argument of 6s squared. Okay, I don't forget this. This is 23x, 21, okay, minus log to the base of 3x plus 7 is actually equal to 2. This is 4x squared plus 12x plus 9. Now, if you look at this equation carefully, using the argument is going to be a bit complicated. I will take the two bases. Let me just take 2x plus 3. The domain of this 2x plus 3 is going to be s must be greater than negative 1. So that 2 multiply x, 2 multiply negative 1 is negative 2 plus 3, that will be 1. Here, 3 multiply negative 1, that will be negative 3 plus 7, that will be 4. So, we use s equal to, okay, the domain is this. The domain of this entire equation is that s must be greater than negative 1. This is greater than negative 1. You have 0, 1, 2, 3. You have negative 1 and negative 2. So negative, okay, we are there. S must be greater than negative 1. So S cannot be negative 2, cannot be negative 1.3, and so on. Okay, with this, we shall analyze the solution. If I take the biggest negative value there, that's negative 5 upon 2, which is negative 2.5, and multiply it by 2, that would be negative 5, plus 3, that would be negative 2. And the argument of a logarithm cannot be negative as well as the base. So negative 5 upon 2 is not the answer. That one has been eliminated. I'll come to the next value of x, which is negative 4 upon 3. That would be negative 1.33. Okay. Actually lesser than negative 1. That would be at the back, close to 1. So that is knocked out. Then I'll take another one again, s equal to negative 2. If I use 2 to multiply negative 2, that's negative 4. Negative 4 plus 3, that will be negative 1. That one is off. Even though this one is not, this one has invalidate, negative 2. Then we come to the smaller guy here, 1 upon 4, negative 1 upon 4. Very interesting question. This is negative 0.25. This must be greater than, this one is actually bigger than negative 1. So we stick that here. That will be 0.25 multiplied by 2. That will be negative 0.5 plus 3. That will be positive 2.5. You come here, 0.25 multiplied by 3. That will be negative 0.75. If you subtract that from 7, that will be positive. So, very interesting question. We can then say, I will say, hence, thus, okay, the values of x are, I will start with the most negative. That's negative 5 upon 2, negative 5 upon 2, comma, negative 4 upon 3. Okay, that will be negative 2. Negative 2, followed by negative 4 upon 3, followed by negative 1 upon 2. Negative 1 upon, upon 4. What are the values of x? So at the end of the day, from the test we performed on all these guys, the only solution is s equal to negative 1 upon 4. So that's the answer. Guys, we've come to the end of another exciting problem. If you derive any value from this video, please give it a thumbs up, share with your learning friends and colleagues. See you next time. Bye.